Today we are going to learn a special instrument called total station. The total station is the combination of all the equipments of surveying. For example, you might be dealt with the dumpy level, theodolite, in theodolite 20-second theodolite, then 1-second theodolite, then auto level, digital level. It's combination of all together. There is one instrument is invented that is called total station. As name indicates, total station. It has the features of all the equipments which are listed right now. So, what are the main title of the today's experiment is practical based on various functions on total station. Various functions like slope, horizontal angle, vertical angle, then setting of offsets. Like that we can perform n number of functions. In your syllabus we are going to deal with the three major functions. Those are horizontal angle, vertical angle and slope distance. Here we can also measure the slope distance as it is one of the laser based equipments and which is reading the reading directly. And next aim of the experiment is introduction to the total station. This is our total station. As I explained in previous section, this instrument is known as a combined combination of all the instruments, such as it's showing all the functions, as well as there is a digital screen here. This is our telescope and this is our object piece and this is our eyepiece, just like our 1-second theodolite or 20-second theodolite. Telescope is remains same and the upper part is known as triangular raw object adjustment. With this we can adjust the object. Here we'll go with again the components of the total station from the bottom. This lower plate is known as a base plate which is going to mounted over the tripod head. This is having a specific tripod which is made of wooden on which it is going to stand, and there is again a 3 foot screws. If you see here there are 3 foot screw. Again same principle for the leveling purpose. The 2 foot screws need to be parallel to the bubble spirit level, then either inward movement or outward movement till we get the leveling of the spirit level. Like that again we need to turn the telescope. The spirit level will be parallel to the 3rd foot screw or perpendicular to both the foot screws. Then we need to again level it with the help of 3rd foot screw. Once the leveling is done, we need to rotate it 360 degrees so that level remains same or not. After that you can see here this is complete assembly. This is the handle. If you remove this handle also there is no issue. The main instrument is below this handle and there is a marking here for the, can you see this cross mark? This particular mark is known as center point of the telescope and that will measures the height of the instrument from the ground level. This is our height of the instrument which is exactly piercing the center of the telescope. Here if you see here, this button is power button. It consists of a battery. Battery can be mounted here. This is the battery. There are 2 removable batteries. And if you on the power button, you can see the display panel is on. The both side there are panel is on both the sides. If you see here both the sides there is panel. This is very useful as whenever functioning is done on one panel, other side student or another operator can see the things. If you see here there is an center here. The center darkest line shows the actual instrument leveling, but it is not exactly leveled. We need to bring it this to exactly center point, then only it will be leveled. Then only we can perform the experiment. The other components are, this is for another battery. We can utilize 2 battery at a time also, 1 battery also it works. And this is a fine adjustment, just like tangent screw in our this is fine adjustment knob and this is a vertical knob. Now telescope is moving like this. If I clamp this one knob, this particular knob, vertical knob, the telescope is not moving now. See, telescope is locked. Now unclamp this one, now telescope is moving. This is vertical clamp. The bottom, this clamp is, this particular knob is horizontal knob. Now instrument is moving horizontally. So I will clamp this one. Now instrument is not moving at all. This is horizontal knob which is once you clamp, movement will not be taken place. Once it is unclamped, movement is taking place. This is for knobbing. Now here there is an eyepiece focusing screw. This is called eyepiece, and this is for eyepiece focusing screw. And the larger one is known as telescope focusing screw. This is going to enlarge the view and clarify the errors. Error usually known as a parallax error. Once it is a parallax error, then we need to keep a palm or white paper. Then only we can eliminate by seeing the crosshairs. Okay. Here, this is the basic component. You can again see the numbers, just like our mobile keypad. There are numbers as well as alphabetical. This is alphanumerical keypad. Here we can name each and every points. It can store more than 2000 points. It has a memory, and again there is a socket here. If you see this one, there is a cable comes to this. With this cable we can also transfer the data to the computer. There is again another slot. If you see here, there is a memory slot. Look at this. We can attach USB cable or memory card is already inserted here. See, we can take the data into this. You might be thinking why this is required, because once the points are considered in this particular, we can transmit or export to the system on software supporting this particular Pentax device, and that data can be exported to the any softwares like AutoCAD drafting software, so that we can draw the contour lines or a profile leveling. So these are the components of the total station, and rest of the practical things will be performed on site, and as well as the keypad notation and functioning will be shown in the on-site execution. Next accessories of this total station is this particular prism. Why this prism is used? Without prism also we can perform the experiment, as it shows the laser. But you can see the prism, this is a special kind of prism. Using this prism, we can carry the survey at one point, keeping the instrument at one point till 5 kilometers. Why? Whenever beam strikes this particular prism, it will be reflected back to the instrument. Then we can read the reading exactly. If you see the arrangement on inside, there is multiple prism arrangement. Like reflection will take place, and that will be reflected back to the instrument. And this will be mounted over the vertical rod, which is having a solid rod with a white and red color, so that it can be holded at a different level also. As instrument can, with the help of tripod, instrument can be adjusted to different levels. This can also be adjusted to different levels based on the availability. So this is another accessory, and with this there is a tripod leg, as well as for this there is an vertical single rod. Why we need to study this total station? This is one of the advanced equipment which is combination of compass, theodolite, dumpy level, and measurement equipment such as electronic distance measurement. As it is consists of a laser, we will be doing everything on fraction of second. So this is one of the best instrument, I say. So we are going to study the various functions of the total station. As we had gone through the components and their functions of the components in a theory lecture, so we will be directly going through the operation. So this is power button. You can see the red mark. This is power button. If you press this one, it is already on. So because I have done the leveling, so we will be showing the center line. This center line is instrument leveling process. Now if I press the enter button, here you can see the screen. Here we are seeing the reading, that is 190 degree 47 minutes 31 seconds. That is a true meridian angle with respect to north direction. So whenever you operate this one, as it is consists of a compass, it will be showing the initial value with respect to north meridian. If your instrument is directed towards the north direction, then only it shows the 0 reading. So, and see, VA means that is vertical angle. I try to bring it to 0, that is 0.03%. That means it is almost a 0 value. So slope distance, I haven't measured the slope distance, so it is not showing the value. Horizontal distance HD, vertical distance VD. Like that we can see all the functions through a laser. We will operate this one, we will go one by one. If you see this one means, if you press F1 means F2 target,
O set means instrument station point, and various function can be shown through S function, mode through the 5. Like that, if you operate, if I press mode again, it goes to another set, discrepancy, angle set, hold, correction and mode. Again mode, if you press, further functions will be shown, that is again what are the functions. If you want to go for a further process, you need to press mode. If you change the mode, various functions will be changing. This is the main important function of a key F5. Now if I press F1, it will be hitting the target and it will be revert back, but I haven't pointed out the target. So we will first point out the target, which point will target the first ranging rod which is exactly behind the, opposite to the instrument. So we will target that one, and then we press F1, that will measure the distance. If you do not target any object, laser will go percolate further and we will be not seeing the exact value. So we will bisect the target first. So we will unclamp it and we move horizontally and we roughly bisect the target. Yes, it is targeted now. Now I will clamp it so that instrument will not be disturbed further. Yes. Now it is bisected to the first ranging rod. If I press F1, then it will be directly reading the value. See, according to the direction, it is further changed to 181 degree, 39 minutes, 11 seconds. So because we horizontally moved, according to the north direction, angle will be changing. So I press F1 means measurement. See, it will hit, the exact distance from this center of the instrument is 6.326 meter, that is distance of a first this one ranging rod. So value is 6 meters, that is slope distance is again same because I already set it to 0. If we want to incline further, that will showing the further inclination value and that will be considering a slopey distance. So here slope is almost 0, vertical distance we haven't taken, so it will not show the vertical distance. So these are the function. So if I offset is again will be showing the 6 meter. Offset means inclined values, we haven't changed the direction of the telescope, so it will be showing the same value. If I go functions, in function there are different tools. Select, if I move F2, that will be moving to another settings, another mode. Reflection, calculation is also there, further obstacle setting. Then if I come to move, if I press F2, there are whatever different functions are shown on the display, 9 functions, we can go to the all the functions. Station points we can mark it out and we will be going through. Mainly in our basic surveying, we will be using the first one. So if you want to go back, we will be going back. How to go the previous screen? By pressing the escape button. Again we back to the previous screen, again from the beginning. If I want to measure the distance again, F1, warning, please observe, whenever the press is whenever we press F1 measurement, we should not be exactly opposite to the telescope, because laser will be percolated, it will harm your eyesight, that will be showing the warning for the eyesight. So again we got 6.326 meter distance, that is exactly previous reading. So we will take another reading to the another ranging rod which is far away compared to this first ranging rod, that is we will unclamp horizontal direction, we will turn it, we will be bisecting second rod. We have targeted the point second, that is a ranging rod, so we bisected it. So we will see the what is the distance from this our instrument point, that is 14.40 meter, and angle, horizontal angle is 207 degrees 12 minutes and 33 seconds. Again I will repeat, horizontal distance is 14.405 meter, earlier it was 6, now it is away from the instrument, so it is giving a greater value, then that means it is exact showing the readings. And horizontal distance and slope distance is same. Why? I haven't changed the vertical movement of the telescope, so this is, that's why we are getting the same value. Now we will move further third point. So we will finish up the actual horizontal angle as well as this horizontal distance. So we will target third ranging rod. I will unclamp the horizontal movement knob, again bisect it, Okay, now angle, horizontal angle from B to C ranging rod is 244 degree 07 minutes 38 seconds. This including the initial north meridian values, and distance will hit the target with my F1 button 16.160 meter. Almost both are at same level. From this point it is also having a same distance. So that is 16.160 meters. This is our third point. Then we'll stop this one. Now we'll take for the horizontal angle. Horizontal, whenever you measure the horizontal angle, along with we will be getting a slope distance which is not exactly same as that of the horizontal distance. We try to understand the keypad functioning with respect to the total station. So I had changed the target. We will not focus on a target. We are majorly focusing on the keypad functions. So here it is showing the initial values. If you see F1, it is a measure, that is short form MEAS, target. Target is setted. So if you take this target, target name is on. So it is again OSET. OSET means if it is any orientation required, then we can press F3. So if you press F3, it is showing the target which is hitting the targeted point. So it is again showing the value. F4 means different functions. If you see this one, there are n number of functions. We are using first application only of this particular total station, that is this one. If you want to go to another, say there are arrows are shown right side. If you want to go to right side, then press F2 because arrow is showing to. Then we are going to the second function of this application. Now move to third application. Now we'll press one more time, we move to fourth application, then fifth. If you want to go again up or down, so we'll come to down, come to this particular point. Then I want to go to left side. This is how we can change the mode. If you want to up side, F3. Just follow the instruction which is shown on the display screen. That's why how we need to operate it. Then next we want to come to original screen, then press ESC, that is escape button. If you press escape button, it comes to original position, that is plane. So again we will try to bisect the object and we will show the reading. Target is bisected. I will press now. F1 means measure. If you see, it is measuring and it will show the values also. See, 165 degrees 40 minutes and 02 second, it is the true meridian angle. So it is showing that value to the target. If you see the vertical distance, because now we have just tilted something, so 3.16 is vertical angle. Now horizontal slope distance is 17.754, and horizontal distance is 17.742. Both are not matching now because we have changed the angle. Now again I request focus on a screen. Now however I have changed the direction further, see slightly vertical angle is 19. Now again I will hit the target and try to see the, I will press F1, and what is the slope distance we will measure again. Look at the screen. Blinking means it's still setting the target. See, now both values are slightly mismatching, means slope distance is 16.597, it is almost 17, and horizontal distance is 16.299. That means it is only considering a parallel to the ground, and slope distance including the slope it is showing. If I change further, it will change value again. And vertical slope distance, vertical distance is 3.133 from the line of sight. This is how we can see the various functions of this particular Pentax model of total station. So this we have found out horizontal distance, we have found out vertical distance, slope distance, then horizontal angle, vertical angle. With the help of one particular key, one application, we can find such more functions and tools. Then we can also record the functions. If you press F3 hold button, reading will be on hold. So whatever we changes do, it will not change. See, I will unclamp it, it will not change the value. Even angle is not changing. Angle is changing, but remaining things are rest as usual. Hopefully you can see this thing. So hold. If you want to go to the display, here it is showing a horizontal angle Please look at this horizontal H angle is horizontal angle at this particular position of the telescope. Horizontal distance 16.2, vertical distance with the line of collimation, that is 3.133 meters. If I change further, it will change again, but need to hit the target, then only it will value will be changing. If you want to see the station point, you can press this lower button. Here it will be ranging the C. You can see on my palm the laser is hitting, so that is directly percolate over the, we already set it on a station point. So I just want to show the function of this target point, and this is the laser light. If you want to see, if you press this one, this will be laser will be percolating through this. You might be not seeing through this particular action. So again this is will be leveling, it is almost center, so we will go enter, it will be having a values. So again mode, escape, display, angle set. Here you can say angle, right angle, left angle, reversible angle. If I change this one, that will be changing again. See here I can change the values also. If I want to select it, select functions, then left, right movement. This is Pentax special functions. Then I will move to the third function, that is function of calculator. Here we can use also calculator. Depend upon the usage and utilization, we can use this particular function. Again if you see this one, I will try to show the memory slot here. Here memory card is already inserted, whichever points you have considered, it will be recorded in this memory point. Here USB cable port is there to directly connect with the computer. The points and readings can be export to the system with the software, and it will be enable the contour map or plan, whatever you want. Even area can be find it out with this particular total station. So this ends this particular experiment, that is various functions of the total station.